The overall goal of this procedure is to use a solution-based fabrication process that combines lithography, electrodeposition, and imprint transfer to produce a high-performance, flexible, transparent conductive film with a self-anchored, fully embedded micrometal mesh.
This method can help address key challenges facing future metal mesh-based flexible electronic devices, such as non-flat surface topography, low fabrication throughput, and high manufacturing cost.
Embedded metal mesh provides several advantages such as crucial surface smoothness, mechanical stability under high bending stress, strong adhesion to the flexible substrate, and resistance against moisture, oxygen, and chemicals.
Our process replaces vacuum-based metal deposition with solution-based electrode deposition, and is suitable for pursuing high throughput, large volume, and low-cost production.
My group helped Dr. Wen-Di Li's group to test the dimensional stabilities of metal mesh fabrication process by patterning 400 nanometer metal mesh with our home-built electron beam lithography system. My student Xiong is going to demonstrate the electron beam patterning process.
To begin EMTE fabrication, clean a 3 cm by 3 cm piece of fluorine-doped tin oxide-coated glass with liquid detergent and a cotton swab. Thoroughly rinse the glass substrate with deionized water and remove traces of detergent with another swab. Sonicate the FTO glass in isopropanol for 30 seconds at 40 kHz. Then dry